This is the second in a series of lessons on bond valuation. In the previous lesson, we had understood that a bond is part annuity, part lump sum, and we had learned to calculate the value of a bond manually. In this video, we will learn how to calculate the value of a bond using Excel. Note that we are not referring to any inbuilt Excel formulas. We will learn how to calculate the value of the bond by discounting the stream of cash flows that we get from the bond. Now, why would we want to use Excel at all? Let's start with motivating that. In the previous lesson, I had presented this problem that I'll continue with in the current lesson. A corporation has issued a 10-year 5% coupon bond that makes semi-annual payments, has a $1,000 par value. Based on your analysis, you believe that the current 10-year yield is 5.5%. What is the value of the bond to you? I had concluded that lesson with the following task for you, the student, that you recalculate the value of the bond with a 4.75% expected rate of return and again with a 5% expected rate of return. If you actually did that, then here is what you would have to do. You would go back to all the formulas that we had used, replace the discount rate with the new discount rates for each part of the problem, once with 4.75%, once with 5%. You would recalculate the value of the bond. You would have got $1,019.72 with a discount rate of 4.75% and $1,000 if you were also expecting a 5%. You would actually need to do the calculations 3 times. Now, for some of you, this may be your preferred method. You may not particularly mind redoing the formulas all over again. In fact, you may actually like it. But let's see how Excel makes our task easier and what additional information does it provide us. Why it might be a good idea for you to actually do the work in Excel. The number one reason why you should be interested or you may like to learn how to use Excel is that Excel purges the need for repeat or repetitive calculations of any kind. To understand that and to set up this problem for calculation in Excel, we will, however, need to visualize the stream of cash payments a little differently than we had done before. So recall that we had visualized the stream of payments that you expect from this bond as the following. A series of $25 payments, those are the coupon payments that will be received for 20 time periods, and a $1,000 lump sum that is the repayment of the par value at maturity. While the payments remain the same, we will view it a little differently for the purposes of doing the problem in Excel. So let's go ahead and see what is going to be different. We are now going to visualize the stream of payments in the following manner. The $1,000 lump sum remains the $1,000 lump sum, but instead of the $25 annuity for 20 time periods, we are going to view each coupon payment of $25 as a lump sum payment by itself. So the $25 received in period 1 is one $25 lump sum received in time period 1, and then this one, for example, is a $25 lump sum received in time period 6. This is another $25 lump sum received in time period 10. In other words, we are now going to visualize the stream of payments from the bond as 21 different lump sum payments, 20 coupons, and 1 redemption of face value or par value received at different time points. So observe, we are just repackaging the payments. We are not changing the payments at all. And how does this help? For this, let us turn to Excel. Here is our Excel worksheet. The coupon payment on the bond is 5% on a par value of $1,000. The term of the bond is 10 years. That's how much we have until maturity. We are going to do a couple of things here. Since payments are made semi-annually, so the number of time periods for which we receive payments is 20. Our first discount rate is 5.5%, but this is an annual rate. It has to be matched up with the semi-annual coupon payments that we will receive, and therefore the discount rate to use is half of this. So I'm going to write a formula that says I take the annual rate and divide by 2. The timeline that we had visualized in horizontal format on our PowerPoint screen a little while ago, we are going to generate the same thing in a vertical alignment here, only because it is a lot easier to work column wise in Excel. So time periods 1, 2, we need them all the way up to 20. Those will go up in increments of 1. Excel will know to keep adding 1 if you highlight both the 1 and the 2 so that it picks up the pattern, and then we will copy and paste. The easiest way to copy and paste something in Excel is to hold your mouse in the lower right hand corner till all you see is the plus sign, and then we drag and drop. Left click, drag and drop. So here I have up to 20. These are the 20 coupon payments. At time period 20, we will also get back our face value. So I'm going to add another time point at 20 time periods. The coupon payments will be received 1 year from now, 2 years from now, and so on. So these are all payments that will be received in the future. So the $25 coupon payment that we are going to receive every half year, we are going to record those as future values that are received. So $25 coupon payment received at time period 1. We are going to copy and paste this. So you can use keystrokes, Control C, Control V. You can right click, copy and paste, but really the easiest thing to do is to hold your mouse in the lower right hand corner till you see the plus sign. I'm going to copy this all the way up to time period 20. I may not have mentioned this when we were doing the problem, but 5% coupon on a par value of $1,000 is $50. But since payments are made semi-annual, so every half year you receive $25. That's where these numbers come from. In the 20th time period, we also get back our $1,000. Each of these is a lump sum. You know how to calculate the present value of a single lump sum. Present value is calculated as future value divided by 1 plus r to the n. We are going to write a formula that does that. So present value of the first coupon payment that we will receive is, so equals future value, so we click on future value, divided by, open parenthesis, 1 plus the discount rate which is here, close parenthesis, to an exponent of the time period at which it is received. So this is our present value formula that you would have otherwise written on your calculator. We have written a similar formula in Excel. What does this number indicate? It essentially says, and I'm reducing this to 2 decimal places, $25 due 1 year from now is worth only $24.33 today. You really want to copy and do the same calculation so many times over, but here is the thing to note. If we copy this formula and paste to the rest of the cells, then the $25, the future value, will be picked up from every time period. The n will be picked up from every time period as we copy. Excel copies formulas using what is called a relative reference. So when this formula is copied down, the inputs also move down. However, if I simply copy, let's see what happens if I just copy from here. So copy, and I go here and paste it. Observe, it returns me the same value of 25. It is not discounting it anymore, because having pasted the formula, it thinks that the rate has to be picked up from D10. That reference has also moved down. It finds nothing there, so in other words, it does not discount at all. We need a way to tell Excel that the rate always comes from the cell B9. In order to do that, we are going to go back to this formula before we copy. We are going to fix the location B9, but we are going to keep the locations E2 and D2 as floating. those should change, but B9 should not. In order to fix the location B9, you click your mouse either in front of B or between B and 9 or after 9, wherever you like, and hit the key F4. When you hit the F4 key, and this is for Windows users only, Mac users, it may be a Shift 4 or a Control F4, you'll have to figure that out, please. When you hit the F4 key, observe the two dollar signs show up. The first dollar in front of the B fixes the column B. The second $9 fixes the row 9, and therefore together they fix the column B9. Let me just copy and paste one time so that you see what this did. I copy, I paste it here. Observe where the inputs come from. E3 is the future value which is correct, B9 the rate which is correct, D3 the time period which is also correct. So now this is a formula that can be copied, and really if you think about it, you would realize that now this makes sense. The same $25 due further in the future is worth less today. So it is worth $23.68. Copy and paste. And now all you need to do for the value of the bond is just sum them all. So here I'm going to go on the side, and I could have done this here as well, except some of you may not be able to see it, so I'll do here on the side. The sum of the bond is the sum of all these present values, and therefore the bond is worth the same $961.93 that you had seen before. In fact, if you would like to put together every piece that we had done manually, we had said we would sum all the coupon payments as an annuity, and we would keep the face value redemption separately. So in order to see that, you can do the sum of the present values of just the coupon payments, keep matching them with your notes. You had the same $380.68 before. This plus this gives you this. So the final check equals this plus this. Okay, I will just put this in bold. So that's how you figure the value of the bond in Excel. Now you might think, well, that took a lot of time. How much different is it from doing it using your calculator? Well, the benefits show up now. Those repeated calculations, in case you didn't observe that, we didn't really do any repeated calculations. We just copied and pasted. I want to do this calculation again with the 4.75% annual rate. Now all I need to do is go here and change this rate to 4.75%, which is 0.0475. I just hit enter, everything recalculates. This is where I save a lot of time, and I have the $1,019.72. If the discount rate is same as the coupon rate, which means you expect the same rate of return as the bond is offering, you should value the bond at par. Do not need to do any repetitive calculation. I just change this rate to 5%, and here we go. The bond is valued at $1,000. So anytime you have to do repetitive calculations, in this case I have to find the value of this bond over and over again, or many different bonds for the purpose of, let's say, doing a homework exercise, a set of assignments, that's where the use of Excel becomes especially helpful. So before I close out this lesson on valuing the bond using Excel, I am going to revert this to the original 5.5%. And this concludes our second lesson on valuing a bond using Excel. In the next lesson, we are going to calculate the yield to maturity, the YTM.